Here I'm going to explain further, demonstrate further on using rules of differentiation or power rule of differentiation. I have this question of y is equal to x square minus 1 over x square to the power of square. So my first step is to simplify. So listen very carefully here. My first step is to simplify. I'm not differentiating, I'm simplifying. So here I apply the FOIL method, I apply algebra. So you have to be very strong in algebra to do differentiation or in calculus. So here I apply the FOIL method. Is those who can do without writing in two factors, we can straight away write. But I'm using this factors form. So is x square and x square will give me x to the power of 4. X square times negative 1 over square will give me negative 1. X square and x square becomes 1. Again, this negative 1 over x square times x square, it will again give me 1. Negative 1. And negative 1 over x square times negative 1 over x square will give me positive 1 over x to the power of 4. So I got this now two terms, x to the power, three terms actually, plus 1 over x to the power of 4 minus 2. Now I simplify further so that everything is in power. So this I will write x to the power of negative 4 minus 2. Now I will start the differentiation using the power rule. So it's dy over dx is equal to, be careful of the notation. Now I apply the differentiation rule. So x to the power of 4, I bring the power to the coefficient, x to the power of 4, reduce the exponent, which is equal to 3 minus 4 x to the power of, reduce, that means minus 4 minus 1 will give me negative 5, and of course this will become 0. So that's how I differentiate my first question. We may not write in exponent and positive, we may write in exponent, positive exponent form this one, x to the power of I can bring to the denominator, but since the question doesn't mention, is silent about it, I am not doing it. Now the question here is 1.2 dx over x cube minus 1 over x minus 1. Here you can see the denominator is a linear, right? Is a linear factor, right? So I will try to factorize the numerator and the denominator and try to eliminate, and so that I can write in the exponential form. So here on the numerator, I have to factorize the numerator. So let's recollect the factorization of cubic. So this is on the numerator is factors is a difference of two cubes, that is a cube minus b cube. I'm recollecting it. That is a minus b times a squared plus ab plus b squared. And actually this is quite straightforward to remember it. It is a cube minus b cube. The two factors, one is linear and the other is quadratic. So it is a minus b is minus here. So this first linear will be minus. Then others will be all of them terms will be plus. So it's a squared plus ab plus b squared. So a plus b will be a cube plus b cube will be a plus b times a squared minus ab plus b squared. So you must understand, if it is a sum of two cubes, then the first term is a plus b, and there is one negative only, which is equal to negative ab plus b squared. So we have these two identities in for factorization: sum of two cubes and difference of two cubes and sum of two cubes. Remember, for squares we have factors for some difference of two squares, we don't have an identity for sum of two squares, only for difference of two squares. Whereas for cube, we have both difference of two cubes and sum of two cubes. So here it is difference of two cubes. So we apply the factorize here. So I am not yet started deriving, I'm simplifying it. So I'll write dx of, I factorize here x cube. So it is x minus 1 times x squared plus 1 into x is x plus 1 squared, which is equal to 1 whole divided by x minus 1. And that's how I explain, that's how I factor simplified. And now I can see here what I'll do. I can know x minus 1 and x minus 1 cancels, so becomes 1, and I can write x squared plus x plus 1. Now everything is now in exponent form. Now I'll apply the rules of differentiation. So x squared will become 2. 2 comes to the coefficient x plus, and the differentiation of x is the power is 1, and therefore I bring 1 to the coefficient, which is again 1, and x to the power of 0, which is 1. That's how I get it. And we don't differentiate further, only one differentiation, we are done with it. Differentiation of 1 is 0, it's a constant. So that's how I differentiate this particular question. So remember, of course, to remind you that I got this cancels out and becomes 1. Now here the second question was f of x is equal to root x times x plus 1 over x to the whole squared. So again, my first step is to simplify before I start deriving it, to make in the x in the power form. So this is now x plus 1 over x the whole squared. I apply the so I will write in the factor form, so it becomes easy for us to do it. Or you can apply the identity if you know it. Then root x times x into x will give me x squared plus x into 1 over x will give me 1. Then again 1 over x times x again will give me 1. Then again here 1 over x times 1 over x will give me positive 1 over x squared. Now here it is simplification. Here it is. Now I multiply it out. Again I apply, I remove the brackets. Again I multiply it out. So it becomes an exponential form. So x to the power of half times 2 plus this 1 plus 1 is 2. So it is 2 times x to the power of half plus x to the power of half times x to the power of negative 2. Root x I can write as x to the, in the exponential form, I write as x to the power of half. Then x to the power of half times x squared. 1 plus 1 is 2, so 2 times x to the power of half. Then x to the power of half times x to the power of negative 2. I wrote this in the 1 over x square in the and take the numerator, I'll apply the laws of exponent here. It becomes x to the power of negative 2. Now what will I do? I apply the laws of exponents. So it is 1 over 2 plus half will give me x to the power of 3 over 2 plus, there's no simplification here, I just rewrite it. Now x to the power of half minus 2, which will give me x to the power of negative 3 over 2. I think I made a mistake here, and this is supposed to be 5 over 2. Yes, 2 rands plus half cent will give me 2.5 cents. So it is 5 over 2. That's how I got the simplification now. Then I start, this is my simplification. Remember this now. It's very important to know that this is simplification of the function. Now I start deriving. So when I start deriving here f prime of x, I write f prime of x. Now I bring the exponent to the coefficient 5 over 2 times and reduce the power by 1. I reduce the power by 1 plus 2 times half and reduce the power by 1 plus negative 3 over 2 times negative 3 over 2 minus 1. Now my differentiation is over. One step, differentiation is one step and then a simplification now. So it is 5 over 2 x to the power of 5 over 2 minus 1, which will give me 3 over 2 plus 2 over 2 becomes 1, then becomes x to the power of 1 minus half. So it is half, and then it is negative 3 over 2 x to the power of negative 5 over 2. So this is how I get my answer here. So very important, I remind once again here, this was my simplification, this is my differentiation one step, and the rest is simplification. Now here, this is an interesting question here, where y is equal to 4 times cube root of x squared and x is equal to w to the power of negative 3. So here, the variables are y, x and w. The question is now y dy over dw. That means I have to write the y in terms of w. So first I have to make y the subject of the formula in terms of w. That's our aim is first. So I have two equations, two functions or two equations, 4 times x to the power of 2 over 3. So first I will change the radical form into exponential form. So this is my equation number 1, and I have x is equal to w to the power of negative 3, which is my equation number 2. Now what I'll do now here is I have to find I need dy over dw. Therefore I must have a function y in terms of w. Therefore what I'll do now here is I know x is equal to w to the power of negative 3. So I put this in equation number 2 in equation number 1. So now 1 becomes, so put here 2 in 1. Therefore now 1 becomes y is equal to 4 times w to the power of negative 3. Yeah, that's how I do it. So w to the power of negative 3 to the times to the power of 2 over 3. So this is my 4 times. I apply the laws of exponents here, and I get 4 times w to the power of negative 2. So it's 3 over 3 is negative 1. This is negative 3 and positive 3 here. So this is my simplification. Now I got a function y in terms of w. Now I can derive dy over. Now I can apply dy over dw. That is 4 times negative 2 w. I reduce the power by 1. So it's negative 8 w to the power of negative 3. You can straight away write the answer. So that's so very important here is the dependent variable and independent variable. So here y is a function of x and x is a function of w. So I have to make y in terms of w, and that is the key here. Again, I am continuing with the dependent and independent variable question. Y is equal to 8x cube and root z is equal to y to the power of 2 over 3. Determine dy over dx. So I think I must take as a straightforward question. There are two equations here. One is y is equal to 8x cube. I put as equation number 1, and I put equation number 2, root z is equal to y to the power of 2 over 3. This is my equation number 2. Now what I want is 5.1 is a question, find dy over dx. So it's dy over dx. I'll use the first one because this is the equation that connects y and x, and y is the subject of the formula already. It's a straightforward one. Therefore, I'll use the first one here. Y is equal to 8x cube, and I can straight away apply the rules of difference in the power rule. 8 times 3 is 24, and reduce the power by 1, 24x squared. I think that was a pretty straightforward question. Now let's do 5.2, which the question here says dz over dy. Therefore, the equation that connects z and y is number 2. So I have to make z the subject of the formula. So that is the key here now. So it says root z is equal to y to the power of 2 over 3. That means I have to square both sides. So squaring both sides, I get here z is equal to y to the power of 2 over 3 times 2. So this is, I'm squaring both sides. So I get z is equal to y to the power of 4 over 3. Now I can differentiate. I apply the rules of differentiation to get dz over dy. So dz over dy will give me 4 over 3 y to the power of 4 over 3 minus 1, which will give me 1 over 3. So that's how I get this. It's a straightforward answer. Now, but only thing is that we have to make z the subject of the formula in terms of y. Now I have to, in 5.3 is dz over dy. That means I have to make z in terms of x. Z the subject of the formula, right? And then with x in terms of x. So what I'll do now here is, you can look at equation number 2 and equation number 1. I'll replace equation number 2. So I have from 2 here, that means z is equal to y to the power of 4 over 3. That's what we got when we simplified number 2. So I put this equation number 1. I put 1 here. I put 1 here. That means z is equal to, I replace y with x. That means 8x cube to the power of 4 over 3. That's how I write here. That means now 8 to the power of 4 over 3 times x to the power of 3 times 4 over 3. This is my x in terms of z in terms of x, sorry, z in terms of x. So z is my subject of the formula in terms of x. Now I can simplify it. Of course, 8 to the power of 4 over 3. If you're using a calculator or 2 cube, you get this becomes 16. 16x to the power of 4. That's what I get. Now I apply rules of differentiation, which is equal to 16 times 4 x to the power of 3. So 16 times 4, you can use your calculator and you can write down the answer, and it becomes 64x to the power of 3. So here we must very careful when there are questions involving more than 2 variables. Even if it's 2 variables, we must make the one the subject of the formula, so that we can write in terms of dz here, dz over dx. So z in terms of x.